So you may need to maximize this because it copied kind of small. Number one, which linear inequality is shown in the graph below? Well, first let's just see that these are all the right-hand side of all these equations. This is all the same line with y-intercept -4 and slope +2. So we definitely have this this line here intercepting it -4 and with a +2 slope. But it's a solid line, which we can rule out B because that would be a dashed line, and we can rule out D because that's equals. So we have this either greater than or equal to or less than or equal to, and we like to take a test point, and our favorite test point, if it's not on the line, is 0, 0. So let's see if it's C. Is 0 less than or equal to 2 times 0, which is 0, minus, that's a terrible 0, 0 minus 4. So you would just read this, is 0 less than or equal to -4? It isn't. It even hurts my eyes just to see that there, so I'm going to cross it out. So we know it can't be C, so the answer has to be A. Which point is not a solution to y is less than, let me rewrite that, y is less than or equal to x plus 9. So not a solution. So, okay, let's look at A. A is, remember, ordered pairs are x comma y, so 4, 15, is that true? 4, 15. Put that into the equation. See, is this true? And I like to put a big question mark over this, and I would read this: is 15 less than or equal to 4 plus 9, which 4 plus 9 is equal to 13? No. The answer is nope. So the answer is A. There might be another one that's not a solution. Well, can go through each one. Number 3, simplify this: m to the third, m to the fourth, m to the eighth. When we multiply like this with the same base, which here is m, we have to add exponents. And to remember that, just think of a really easy example. So, for example, 2 to the third times 2 squared. You know that this is going to be 2 times 2 times 2. That's 2 to the third, right? So that's this one. 2 to the third is 2 times 2 times 2. And then we have times 2 to the squared. That's 2 times 2. Right? That's this one. And we know that we just count the exponents. That's 2 to the fifth. So this kind of confirms that you add exponents. So you had 3 plus 4 plus 8 is 15. So there's our answer. Simplify a squared b to the seventh to the fourth. Well, there's an easy way to remember this for exponents, and that's just you multiply the exponents when you have a power to a power. Or again, you should just confirm this, that take a very simple example like let's do 2 to the third to the squared. Well, that's 2 to the third times 2 to the third, and we know from this one we add exponents. That's 2 to the sixth. How do we get from how do we skip the step and go right from here to here? We can see we multiply 3 times 2 to get 6. So how does this one work? This is what happens if we have 2 different bases in here. So let's answer an easier question. Let's answer a squared b to the third, the whole thing squared, just to remember our exponent rules. This is a squared b to the third, right? It's one of them. Now we have to square it, so times a squared b to the third, and this is a to the fourth, right? There's 4 a's here, and there are 6 b's. So again, how do we get from here to here? You can see we just we distribute this. It's 2 times 2 is 4, and 2 times 3 is 6. So the answer here would be take this 4 and distribute it across both of these exponents. Just following the exponent rules. That's a to the 8th, b to the 28th. Solve 7x plus 3 is greater than minus 32. So we have an inequality. We still have to treat both sides equally. Let's subtract 3 from both sides. Minus 3, minus 3. And on the left-hand side, we'd have 7x. We still have a greater than sign. And we have minus 32 minus 3 is minus 35. Now divide both sides by 7. Now dividing both sides by a positive number does not change the inequality. If we divided by a negative number or multiplied by a negative number, it would change the inequality to the other way. And you kind of know that already if you have, so for example, let's take an easy one that we know. If minus 1 is greater than minus 2, right? So if you look at the number line, minus 1 is, here's 0, here's minus 1, and here's minus 2. Minus 1 is greater than minus 2. Let's multiply both sides by negative 1. So times negative 1. See what happens. Let's see, times negative 1. Then we have 1 and 2. Well, which is, right? So which is greater? 1 or 2? 2 is greater than 1. So you can see that multiplying by a negative number in this case flips it, and in general it does. But here we divide it by a positive, so 7x divided by 7 is x. And we have greater than. Minus 35 divided by 7 is minus 5. At minus 5, because it's not an equality, we put a big open circle, because it doesn't include minus 5, and we have greater than, so we shade that way. That is a crazy straight line. Okay, page 2 coming up.